All right, let's turn our attention to the constellation Pictor. Now, if you were to just glance up at the southern sky, you'd probably skim right past it. It seems, well, pretty unremarkable. But that unassuming patch of darkness is actually a stage for some of the most profound discoveries in astrophysics. It's a place that forces us to ask the biggest questions about creation and our place in the cosmos. So today, we're going to unpack the science and the philosophy that transform this quiet constellation into nothing short of a cosmic manifesto.
So let's start with the basics. What are we actually looking at? Well, honestly, not much. Pictor has no first magnitude stars, nothing bright that grabs your attention. It's really just a faint scattering of stars, completely overshadowed by its brilliant neighbor, Canopus. It's the definition of an underdog in the celestial sphere. But here's the twist. It's precisely because it's so quiet and unassuming that it has become one of the most important places for modern astrophysics. Think of it like this. The universe is writing its own history in this constellation, and we are, for the first time, actually learning to read the language. This isn't about mythology. This is about watching cosmic evolution happen in real time.
Okay, so our first stop on this journey is a star system called Beta Pictoris. This system is, without exaggeration, an astrophysical triumph. When we first pointed our telescopes at it in the 1980s, it fundamentally rewrote our understanding of how planets are born. It was the first time we got a direct look at the process. The first major breakthrough was getting an actual image of its circumstellar debris disk. Now, this was a huge deal, the first one ever directly imaged. So what is it? Just imagine a gigantic, spinning disk of dust and gas, the leftover raw material from the star's own formation. But don't picture something static. This is a chaotic, dynamic, active construction site for an entire planetary system. And the physics inside that disk? It's just incredible. You've got these small bodies, planetesimals, that are constantly smashing into each other, creating clouds of fresh dust. But here's where it gets really clever. Astronomers noticed the disk wasn't smooth. It had warps, it had gaps, it had these beautifully defined rings. And those features were not random. They were gravitational fingerprints, clues left behind by some massive unseen object that was plowing through the debris, carving out its own path. It was the telltale sign of a planet in the act of being born.
And then, in 2008, theory became reality. The predictions were confirmed. Using advanced imaging techniques, astronomers were able to take a direct photograph of the culprit, a massive gas giant, Beta Pictoris b. This was a watershed moment. It was one of the very first times an exoplanet was actually seen, not just inferred, but directly observed. We had graduated from simply finding planets to watching them form. You see, that's the real power of the Beta Pictoris system. It's a mirror to our own deep past. When we observe this young, chaotic system, we are essentially looking at a snapshot of what our own solar system probably looked like 4.5 billion years ago. It's a time capsule, a direct glimpse into the violent, creative process that ultimately gave rise to Earth.
Now let's pivot to the second incredible story hiding within Pictor, a star known as Kepton's star. This one presents a totally different kind of mystery. It's not about birth, but about origin and immense, almost unimaginable age. Kepton's star is essentially a galactic fugitive, a refugee from a long-dead galaxy. So the first clue that something is really weird about this star is just how fast it's moving across the sky. You know, most stars seem fixed from our perspective, but Kepton's star has one of the highest proper motions ever recorded. It is visibly racing against the backdrop of more distant stars. It's not moving with the local flow of traffic in our part of the galaxy, it's cutting right through it on a completely different path. And the reason for its bizarre trajectory? It's not from around here. Kepton's star isn't native to the main disk of the Milky Way, where we live. Instead, it belongs to the galactic halo, a vast, spherical cloud of ancient stars surrounding our galaxy. The prevailing theory is that this star was actually born in a separate dwarf galaxy, which the Milky Way then captured and, well, devoured billions of years ago. Kepton's star is a relic, a survivor of an act of cosmic cannibalism. But here is the most mind-bending part of all. We've discovered that this ancient, fugitive star has at least 2 planets orbiting it. Now, let's pause and really consider what that means. The star is estimated to be about 11 billion years old. That makes its planets among the oldest ever found. If you look at this timeline, Earth is about 4.5 billion years old. The worlds around Kepton's star have existed for more than twice that long. If life were to have risen there, it would have had a 6 billion year head start on us. The implications of that are staggering. So we've seen the cutting-edge astrophysics, but now let's switch gears and talk about the constellation's history. Because Pictor isn't ancient. It has no roots in Greek or Roman mythology. No, it's a product of the 18th century Enlightenment, created by a brilliant French astronomer named Nicolas-Louis de Lacaille. While mapping the uncharted southern skies from South Africa, Lacaille decided to do something completely radical. He looked at the northern constellations, filled with gods and heroes and mythical beasts, and he rejected that entire tradition. His project was different. He wanted to use the blank canvas of the southern sky to celebrate human achievement, the tools of reason, science, and art. And that's exactly what he did. Lacaille created a kind of celestial workshop in the sky. He named new constellations after scientific instruments like the microscope and the compasses, and he named others after the tools of art, like Calum, the sculptor's chisel. And right there among them, he placed Equuleus Pictoris, the painter's easel, later shortened to Pictor. It was a statement. Human creativity stands on equal footing with scientific discovery. So because Pictor has no ancient legend, it's open to a new one. A modern mythology, if you will, one that's informed by everything we now know about the universe. The name itself, the painter's easel, gives us the perfect metaphor to tie all of these threads together. In this modern myth, we can see the universe itself as the artist. The easel, then, represents the fundamental laws of physics, the rigid framework upon which everything is built. The paints are the raw materials, that primordial gas and dust we see swirling in the Beta Pictoris disk. And the picture being painted? Well, that's the emergent complexity of the cosmos itself, planets forming from dust, life from chemistry, and consciousness from biology. And so, when you put it all together, Pictor truly becomes a manifesto written across the sky. It reminds us that the universe is both a physical system governed by precise, predictable laws, and at the same time, it is a grand, creative work of art, a process of continuous emergent creation. It is both a machine and a painting. Which, of course, leaves us with one final profound question. If we accept this metaphor, if the universe is indeed an artist, and the formation of stars, planets, and even life is its creative act, then we are compelled to ask, what is the final picture? What is the universe trying to paint? That is the question Pictor leaves us to contemplate every time we look up at that quiet, unremarkable patch of sky.